Ladies and gentlemen, thank you for attending this webinar called How to Get Rid of Costly Magnets in Electrotechnical Devices. My name is Patrick Lombard, Head of Application Team dedicated to electrotechnical devices. So the content of this presentation is split in different parts. So first I will present CEDRAT and its partners. Then I will switch to an history of magnets and prices. Then we are looking at different solutions available. And for each solution, you need to have good tools for modeling. So we will review some of interesting tools. And we will look at one example to see how to use these tools before the conclusion. So CEDRAT is involved in the electrotechnical devices, in the design of electrotechnical devices, and we want to provide tools for each step of the design process, starting from specification to the design, optimization, verification, and system integration before having a product ready to be built. So we have different tools allowing to analyze devices from energy generation to final conversion. So you can see the different tools adapted to what you want to analyze. And the last tool we have is an optimizing tool called GotIt. So who is CEDRAT? CEDRAT is a group with 3 companies. CEDRAT was founded in 1971. So it is based in France, in Grenoble. We have a sister company in USA called Maxsoft, founded in 1986. And we have also as partner a German company called Adapted Solutions since 2006, which is providing us Fortunus tool. So this represents 70 employees and 15 doctors. The turnover in 2010 was about 6 million euros. So our products are distributed worldwide. So we have distributors in America, North and South, in the Southeast, and also in Europe, in which we have many partners and distributors. What is our field of line? In fact, we are dealing with software solutions, so we provide software solutions, Flux and other products. We have also a consulting team, and we also take part to European research projects. And the third activity is training courses dedicated to learn how to use efficiently our tools, and training courses dedicated to a specific topic, such as motor design, for instance. So this is the end of this short presentation. Now let's switch to the history of magnets and price, just to give some ideas. So the magnets are a very powerful supply of energy. You can find magnets nearly everywhere, from pins on your fridge through motors, in different configuration. You have pumps, lifts, air conditioners, cars, hard disk drives. You have actuators, transformers, wind power, just to quote a little. So for sometimes magnets were cheap, and now they are very expensive. So how to deal with it? How to overcome this problem? So just a few recall about magnet history. So they were known since 500 after death by the Chinese. They were used at the beginning as a compass. And in the beginning of the 19th century, they were used with phones. In 1982, 1984, we discovered neodymium Ferber magnet, protected by patent. And after 2002, 2004, there is no more patent. And the Chinese industry is ready to sell magnets to the world. So why magnets are so interesting? In fact, if we look at the energy of magnets versus time, so in fact, in the beginning of 19th century, we have a low energy magnet, and in 1992, we discovered neodymium Ferber magnet, and now we have very high energy. If we plot here remnant flux density against magnetic field, we can see the main characteristic of the three main types of magnets. So the ferrite magnet with low value of remnant flux density, alnico magnet with very high value of remnant flux density but low value of coercive field, and the rare earth magnet, neodymium Ferber magnet, with high value of remnant flux density and also high value of coercive field. So these magnets are more interesting, of course. So now if we look at rare earth metal supply in 2008, just to have an idea of the production, depending on the different components of the rare earth magnet, just to have an idea of the price. So the dysprosium was around 10 euro by kilo in 2003, and it is now 320 euro by kilogram in 2011. So it's more than 30 times more. And most of the magnets are coming from China, 97%. Main suppliers of magnets are China, and then Greenland, Canada, Australia, USA, and Russia. Just to have a look of trends in Chinese export quota for rare earths. So between 2005 and 2010, we can see in green the Chinese export quota, so decreasing. In blue, we have the official rest of the world demand from China, and in red, we have the actual rest of the world demand from China. We can see a drop in 2009 corresponding to the crisis. And we can see that in 2010, the quota are very low compared to the real demand on rare earths, explaining the rise in the price. Just to have a look on a specific component, the praseodymium component, to look at the price between 2008 and 2011. So we have seen that in the beginning half semester of 2011, the price has been multiplied by 4 to 8. So here you have a list of prices, so you can see that all the different components have been multiplied by 4 to 8. And this is not speaking about delay of delivery when you want to get some of these magnets. So what are the trends on the demand? In fact, if we look at the use of rare earth magnet, the hard disk drives, they cannot function without rare earth magnet, permanent magnet, and formally they represent 70% of neodymium Ferber magnet. Now, if we look at hybrid vehicles, motor generators contains 1-2 kg of neodymium Ferber, and this application is set to grow to between 10 million and 20 million vehicles by 2008. If we look at the new designs of one generators, they are also using a rare earth magnet at a rate of 0.5 ton per megawatt. So this application alone has the potential to increase rare earth demand by 25% per year, above current production. So the trend is not to decrease the price. How to deal with this demand? So now let's switch to the next part, explaining the different solutions which are available to us. So first, the first solution is to have new production, new suppliers. So in fact, new suppliers are coming from Canada, Australia, and Greenland. As it is more expensive, you can make more benefit from extracting and delivering these magnets. Now, the solutions that are available to us right now, it is first to try to optimize existing design in order to decrease the volume of rare earth magnets for the same characteristics. So you need optimization. Second is to use magnets adapted to a given remnant flux density and magnet resistance to demagnetization. Third solution is to modify the design for other type of magnets, cheaper, so to use ferrite, for instance. And another solution can be to modify the design to remove magnets. So you can use other technology, for instance, induction motor instead of a permanent magnet motor, or you can use new technology completely different.